It's a big, exciting Materion world. From the cell phones in your hand to the satellites orbiting the Earth, we are all around you. Come inside Materion to meet the people and hear the stories about how we bring it all to life every single day. Join us as we talk to our subject matter experts about topics and trends that are truly changing the world.
Hello, I am Melissa Mull, your host for today's Mind Over Materials podcast, and I'm joined today by two technical experts, Mr. Jeff Hart, our AM Product Line Director, and Dr. David Van Heerden, Global Applications Engineering Manager, who are here to talk with us about this relatively unknown material at the heart of 5G and IoT revolution. So Dave, let's get started with you. For our audience, why is 5G so important for everyone today?
So 5G is essentially the new set of standards that have been set up by the FCC that are going to replace what's 4G currently in your phone and are going to significantly change the way you interact with the digital world. So at the moment, you can imagine if you're going to download a movie, it's going to take you a long time. It's going to take you, 5-10 minutes. Oh my goodness, to download a movie. Imagine that's 6 seconds. Imagine that the bandwidth now, not just that, but self-driving cars, we've all heard about for years and years, that's coming, right? It depends very heavily on a very stable system where in fact you can't lose connection to the system. You can't lose connection to the servers but that's also going to be healthcare. That's also going to be your home from now on out. That's going to be the factory of tomorrow. It's huge. It's really going to change everything in our world, the digital world, the way we interact with it for the next couple of years.
That sounds very fascinating, and I can't wait to learn more. So, Jeff, before we get too far into this broadcast, can you tell our audience what Internet of Things really is? Can you elaborate further on that?
The Internet of Things is made up of billions of smart devices that range from minuscule chips to wearables like a smartwatch, to your household appliances, to large machines that run factories, and they all communicate with each other through the internet. It's essentially going to create a world in which everything is connected, from your watch being able to tell your doctor that you've got something wrong with your health condition, to cars being able to talk on the road so that you can have autonomous driving, to your refrigerator telling you while you're at the grocery store that you need milk and bread. So there's a lot of things that the Internet of Things, and I've heard it called the Internet of Everything. Someday everything will be connected.
Oh my goodness, that sounds amazing and scary all at the same time. So Jeff, before we dive into more detail about aluminum targets, can you introduce us briefly to Materion's advanced materials business and some of the solutions that you guys provide to Materion customers?
Yeah, Materion's Advanced Material Group is made up of 4 business units that is comprised of premium targets, microelectronics packaging, advanced chemicals, and large area targets. The aluminum scandium targets that we're talking about today are part of the premium targets group. The premium targets group really focuses on making hard to make niche materials that make devices that enable 5G to work. We also have precursors for ALD. We have the ability to refine gold, to do shield cleaning, precision parts cleaning, and do the whole value chain for our customers. The advanced chemicals group does a multitude of inorganic chemicals. And so if it's on the periodic table, there's a good chance Materion can provide it for you.
Wonderful. Thank you for that explanation. So Dave, let's transition over to you. Can you tell us what exactly an aluminum scandium target is?
So aluminum scandium spurring target is a disc. Imagine in your mind, it's about the disc of material, somewhere between 12 and they say 16 inches in diameter. Pretty thin, actually, only about a quarter of an inch thick. Okay, and it's used in a spurring tool to actually deposit very thin forms of material onto silicon wafers that you'd have heard of previously. The material itself is it's an alloy that's made by metallic casting of material. It's highly uniform, very high purity, very low impurity levels, and very heavily engineered so that when I put this in my sputter chamber and I try and deposit my film, that the film is very consistent wafer to wafer. has exactly the same chemistry, exactly the same stresses in it, exactly the same compounds are put down on it. So it's a highly engineered thin piece of metal that's actually used for making, and what it's used to do is actually to deposit not scandium aluminum, but actually a nitride, scandium aluminum nitride, which is really cool material because it's actually piezoelectric. So and this piezoelectric is really what's at the heart of those filters we talked about earlier. So the target is a very, very simple piece of heavily engineered metallurgical material that's used to deposit very complex films.
So Dave, what makes Materion stand out from other aluminum scandium targets and manufacturers in the marketplace?
So as I said, the material itself, the basic, I'm a metallurgist, and it's literally just scandium and aluminum. That's pretty much as simple as it gets in metallurgy, a binary system. But in fact, what's hidden behind that is a whole lot of very complex engineering to create the microstructure and the chemistry and all that stuff in the target to give you the correct film properties. So two parts about that. The first part is that it's very heavily engineered. We've had a group of up to, I think, 7 or 8 engineers that have worked on this for 6 or 7 years to actually make this material. Okay. The second thing is, even when you make it, it's not obvious it's going to work on the wafer. So what we've actually done is we've partnered with our customers, and we'll make it, they'll test it, and we'll work together to actually create a material which is uniquely tailored to their particular processes. Okay. And then in addition to that, it has to run in a sparring tool in very high volume, consistent target to target. And also that was developed in conjunction with it. So it was basically combining a bunch of very smart PhD engineers with the engineers and our customers to make these uniquely tailored products that allow them to make these films.
Wonderful. Thank you for that further explanation. So David, how did Materion's advanced materials team respond to these challenges? And what's so special about our products?
So the way we respond to these challenges, most of the people in Materion, certainly in this division, tend to be metallurgists and material scientists. Most of the people at the fabs, as you can imagine, are actually physicists and people that run sparring tools, both enormously smart people, but getting them to talk to a common language, to be able to say, if we do this to our target, it does this to your film. Most of our customers had never really thought about there being a lot of engineering in the targets. So actually sitting down with their engineers and explaining what targets do, and then working with them to understand, if I do this on my target, it does this in your film, was really the magic part of being able to do it. And that was we've been able to partner, I think, better than anybody at being able to do this with our customers. And that's allowed them to very rapidly develop products, which is a great advantage to them, to get the properties of the films they wanted consistently, and for us to develop processes around those products that we could deliver the targets in high volume.
Thank you for that so very much. So Jeff, coming back over to you, can you give us some insight into what's next for Advanced Materials Target Team?
Yeah, absolutely. So smaller, faster devices are really pushing the limits of materials today. So as you can imagine, these devices get smaller and smaller. The next generation semiconductor devices are talking about having, a 3 nanometer line width. So 3 nanometers, much smaller than the diameter of a human hair. And so the materials are being pushed to their limits. So we're working on a lot of next generation high purity materials to be able to handle these requirements. And in addition to that, there are also, as more and more things go into the Internet of Things, you need to be able to store and quickly retrieve data from these internet devices. A lot of our focus right now has been on advanced memory solutions for things like an STT-MRAM or a PC RAM that are next generation memory devices.
Can you give us a success story for what you were just talking to us about?
I have a good example. Materion was approached a couple of years ago by a large wireless company looking to make bulk acoustic wave filters out of compositions and tolerances that none of the rest of the industry had even considered. They chose to work with us because of our excellent reputation and our willingness to work on challenging materials that were at the cutting edge of the industry. We worked intensively on optimizing our materials for their processes and designs, and developed a product with them that helped them win multiple design-ins at end customers where they're currently producing in high volume. And when I say high volume, I mean they're making billions of devices. we still work closely with them, and we're developing with them the next 2 generations of wireless products together.
Wow. I mean, like I said earlier, this sounds really scary all at the same time. It's very fascinating. I'm thinking about things that we have today, right? I'm aware of watches as wearables and obviously our cell phones, but you guys are talking about businesses and healthcare units of the future. So do you actually have customers right now that are developing those applications today? Or is this just an idea that they want to move towards?
Now, that's a great question. We have customers that are currently today making some of these devices, making some of these connections possible. And then there's a lot of the next generation products that are going to make it faster, better, more reliable, for doctors to make better decisions, for autonomous cars to make the right call. Should I brake? Should I speed up? Do I need to avoid an oncoming person in the road? So there's a lot of things you think about that, if you really want smart devices that are going to truly be the heart of what our future is, they certainly need to be able to be extremely fast and be able to make the same decisions that a human would.
Absolutely. Well, thank you for giving us just a little bit more information. And I want to thank you both for providing us all with great information about Materion's aluminum scandium targets materials. If you would like to get in touch with our experts, feel free to reach out to them on LinkedIn to continue this conversation. You can also visit Materion Corporation on our social media channel or check out our website for more information. Thank you so much for joining us today, and have a great day. Goodbye.
Thank you for tuning in to this episode. Be sure to follow Materion on our social media channels, as well as visit our website for more information about our innovative material solution.